Okay, ladies and gentlemen, let's talk about similar triangles and similar polygons. Now, this is two sections in your book. It really doesn't need to be two sections because, again, let's just talk about something very quickly. Congruent means two things that are exactly the same size. In fact, if I had my little sticks, we go over two absolutely congruent figures, okay? Similar figures are figures that are going to be the same shape, but maybe not necessarily the same size. So same shape, not necessarily the same size, okay? So that's what we're going to be looking for. Now, similar, again, as I mentioned in the last piece on proportion and ratio, you have a couple things here. To be similar, two figures have to have sides that are proportional. Doesn't mean some are proportional, it means all are proportional. So in this case, 1, 2, 3, 4, 5 sides. 1, 2, 3, 4, 5 sides. All 5 sides that are corresponding to one another have to be proportional. They would have to fit some version of this proportion, and all sides would have to be able to fit that test and be able to be cross multiplied to be equal. Now, additionally, all angles have to be congruent. So you'll notice I've written it A, B, C, D, E, only because it's easy and alphabetical. Goes with F, G, H, I, but if you'll notice, we'll follow them around. A and F, B and G, H and C, I and D, J and E. They go together, and so that's how they would go. You can't mix G to E and B to I. Okay, you can't mix them up. They have to go in that order, and the sides have to be in the same setup. So sides have to be proportional, angles have to be congruent. If this is 6 and this is 8 and this is y and this is 10, you should be able to find y by using the proportions just like we did a little bit ago. 8 is to 6 as 10 is to y. Be able to cross multiply and find that. You have 8y equals 60. Y equals whatever 60 divided by 8 is. And so let's see here. We got 60 over 8. We have 15 over 4. There we go. 15 over 4. So you have 3 and 3/4. 3 and 3/4. Something like that. That doesn't make sense. 15 fours. No, I'm sorry. It'd be 4 and, well, it should work out. Okay. So you find it, and that's what y should equal. Now, in this case, what we're going to do is we're going to have to be able to say what pairs go with what. Angle ABC would have to be therefore congruent, actually, because angles have to be congruent to FGI, to angle FGI. ABC, FGI have to go there. They have to be proportional. Okay, so you end up with, oh, there's my problem. That's a 2. I knew there was something wrong there. Okay, so 7.5. That makes a lot more sense. So similar polygons. The nice thing about similar polygons is they're relatively easy because that's just what they are. You can find them from there. Now, if we go to triangles, triangles work in the same way because triangles are polygons. However, we know quite a bit more about triangles. And so let's talk about some of those things that we already know about triangles in relation to similar figures. Now, I've drawn two figures here, and I've said at best they are similar. They might be congruent because here's the thing. If two figures are congruent, they are also similar. Now, let's take and assume for just a second that if these two figures were indeed congruent, and they were congruent, let's say by side, 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 okay, well, would it make sense that they could also still be similar? Well, if this is the same as this, as long as this is the same as this, and this is the same as this, that would make all the sides proportional. It would just be in a ratio of 1 to 1, because whatever this is, this is. And if the sides are congruent, then automatically all the angles are congruent. So if all the angles are congruent, then that would qualify as well. So if they are indeed congruent, then they are similar. So side angle side, same reason would work. Now, the one thing we can't use is side angle. We've talked about that because they can have ambiguous cases. They could have a side, and one angle, or a side, and another angle and look very, very different. So those would not be congruent. Likewise, if instead of congruence, we were talking about similarity, if they're good enough to be congruent, they're also good enough to make them similar. The difference is instead of all angles on all sides being congruent, all the angles have to be congruent and the sides have to be similar or proportional. So if this were indeed a 6 and a 5, if this were a 3 and a 2.5, and if this were a 4 and a 2, these would indeed be similar by side, because the ratio of the sides would all be the same. Now, in this case, side angle side would also work for us, because if these sides are proportional, but the angle between them is indeed congruent, then that third side is automatically going to be proportional, so that works out. Now, one thing that we didn't talk about that didn't work for congruent was angle. Angle would not have been enough to make two triangles congruent. In fact, even if you had three angles, angle, that wasn't enough for it to be congruent, because maybe it was a big triangle, or maybe it was a small triangle that had the same angles in it, but they were just a different size. So for congruence, it wasn't good enough, but it is good enough for similarity. If I know any two angles of two triangles are congruent, then automatically, how do I know that the third angle is by default already congruent? Well, because third angle theorem says if I have two angles, I can automatically find a third. If I have two angles, I can find a third. Well, if these two are the same already, automatically that third's got to be the same. So here, if I have the old congruent ones, angle, side, angle, that's good enough to be similar because it already has two sets of angles. The side really becomes extra. If I have angle, angle, side, the same thing happens. Because I already have two angles, the side in essence becomes extra. So all of these are ways to prove triangles are congruent, but all of these are also ways to prove them similar, including a new one, angle, angle. Now, one thing that you might need to be careful of is, do we have enough to prove ABE congruent to ACD? The question becomes, do I have enough between these two to make them similar? The answer is yes, I do, because I have two parallel lines. Because these two lines are parallel, this angle here and this angle here are corresponding. And automatically this angle here and this angle here, they are also same side of the parallel line, same side of the transversal. They're also corresponding. So I have angle, angle, and I'm good enough to say now that triangle ABE is similar to triangle ACD, because angle, angle theorem. Now, by the way, technically I could go angle, angle and do it easier. I don't even need those two, because is this angle reflexive to itself? Is angle A in both triangles at the same time? Yes. So I have angle, 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 angle. So there we go. That's enough to prove two triangles similar, which also means that these sides are going to be proportional. So if I have 4 and 3, and I have 6 and x, I can now use these triangles to find what x is. So if I have 6 goes with 4, then I have 6 plus x goes with 4 plus 3, which is 7. So all I have to do now is cross multiply, and I get 42 equals 24 plus 4x, and subtract 24 from both sides. And I come up with 42 minus 24 is 18. 18 equals 4x. Divide both sides by 4, and I get 9 halves, which is 4.5, which would make sense. So it is 4.5. So using this information and your basic knowledge of algebra, you should be able to do the homework as assigned.